So let's continue talking about display design. Sometime back, a very good graphic design professor named Ed Tufte came up with this way of thinking about graphic representations that I really liked. It was originally derived from print media, back when we got most of our news through newspapers, of course, and the ink in these newspapers was expensive. So you were cranking out so many newspapers, going out to so many households, that you wanted to reduce the amount of ink. And he focused on increasing the amount of data and reducing the amount of ink, which tended to produce really simplified types of graphics. So he defined two kinds of ink. One that was data ink. This ink was absolutely essential to present the data. And then the kind he wanted to get rid of was sort of non-data ink. That is, ink that was really redundant, or more really just used to elaborate or decorate what the newspaper was showing. So here's an example of this. Here's a display that's chock full of non-data ink. So for example, over here it says percentage of adults. Up here it also says of percentage of adults who smoke in England. Over here, 1974 to 1994. Over here you can see the years 1974 to 1994. So you could potentially get rid of these years. You could potentially get rid of this this label over here about percentage of adults. These are clearly years, especially since these are clearly years. You could probably get rid of this thing that says year. You probably don't need the fact that it says 45% here, since it's obviously 45% when you look up here. You probably don't need these lines going across and so forth. And what ends up happening is when you take away these non-data ink, you end up getting a drastically simplified graphic. And that's a nice way to think about your user interface designs from a human factors perspective as well, is get rid of as much sort of noise ink, non-data ink as you possibly can, so that you're really just showing at all times just the information that's really critical to somebody understanding what you're showing. Here's one of the reasons that you would want to get rid of this non-data ink. This is called the Hick-Hyman law, which is a law that looks at reaction time. And basically, it basically shows that the more things you have to select from, the more your reaction time goes up. And of course, it provides a formula for doing that. Reaction time equals some constant plus a slope beta to the log base 2 of n. So basically, as you increase n, the number of choices you have, then the reaction time increases. So you want people to be able to use your software interface, or whatever user interface you're creating, as quickly as possible. So you want to reduce the number of choices that can possibly be made. This, more importantly, from a human factors research standpoint, provides a way of predicting how much each additional item added to your interface will cost in terms of user speed. On the other hand, it's often helpful to combine things like pictures and text together. Pictures are really important for speed. We can grasp them really quickly, but text tends to help accuracy. And as I just covered a moment ago, try to be as minimal as possible. So what you're constantly trying to do is provide only the information that's going to help people's performance, and take away the information that's going to hinder their performance, which of course is a really difficult thing. I often tell people that design is an exercise in trade-offs. You're constantly figuring out what to include and what to remove. But you should try to include those things that are going to improve human performance and satisfaction, and remove those things that aren't. So I'm referring to symbols here. Probably the most common symbol type that we'll deal with, or that you'll deal with, will be icons. You're typically looking for a couple things in the design of icons. One is you want people to be able to recognize it, and you want them to be able to understand it. And there's some ways to go about doing that. Recognition tests, for example, you could provide words and have people match the symbols to the words to make sure that they could understand them quickly. You could even do that in a reaction time paradigm where you have them do this as quickly as possible. And you can entertain different kinds of symbols to see which ones get categorized fastest. Those that get categorized fastest are most easily recognized, and those are the ones you should use. It's also the case that sometimes you can guide attention to certain areas just by making that one area look different than whatever's in the background. These are called pop-out effects, and these are great examples of them. Here's an example just by gray value. Oops, I did it again, sorry. I think that was a song. Wait, okay, let me go back here. There we go. So here, you can see just the gray value, that's white. Everything surrounding it is black, so this pops out. This is just a difference in shape, so this pops out. The same thing here. These are very simple ways to sort of get people to recognize things really quickly. And you can do that guiding their attention through whatever task you're taking them through. So it'll be that simply whatever you want them to pay attention to, you'll make it different than whatever's in the background. That provides context for what's in the background so people sort of know where they are in their task, but at the same time it also helps focus their attention. So choosing the right display often really depends on a whole lot of things, like all these user characteristics like their age, their training and education, previous knowledge, and so forth. Not surprisingly, it depends on their environment. Are they driving or flying? What's the regular ambient light and noise like? What's the glare like, and so forth? And also, what are people's goals and tasks? Are they navigating? Are they controlling something? Are they making decisions? Are they learning? All of these things go into determining what is going to be the best display. And you have to sort of think these things through when you're working on the design of a display. So there's one type of display that you could look at has to do with dynamic information. Dynamic information really fall into four categories. There are quantitative readings to read a precise numeric value. That would be something like if you've got a digital speedometer on your car, that would be a quantitative reading. A qualitative reading is to sort of provide you with an approximate value or discern a trend. That would be something like if you have an analog speedometer on your car. You can see that the needle is going up, or you can see that it's going down, and you can generally see what the speed is, but it's not perfect, not like a quantitative reading. There are check readings to determine if you've got several things you need to look at the same time, then those things that you're looking at should all look fairly similar and be within normal bounds. And then finally, which we won't get into too much, but they cover it in your book a little bit, there's situation awareness information displays, which projects the status of elements into the near future. So they're sort of predictive displays. And we will talk a bit about it in a future video, but it's covered a bit more in your book.